A simplified form of a radical expression. A radical of the form the nth root of a is simplified when the radicand a contains no factors that are perfect nth powers. Now, I know y'all are quite good at this from geometry, but remember when you did the square root of 20, you can do this in your head without showing this middle step. You can think of 20 as 4 times 5. So 4 is a perfect nth power. Since it's a square root, it's a perfect nth power. So this is going to end up being 2 radical 5. So that's what we're going to be doing with third roots and fourth roots. And then another just kind of run through. Remember that if we're doing the square root of x to the 9th, then in my head what I'm thinking is that I've got 9 divided by 2, and it's going to go 4 times with a remainder of 1. So this is going to, I've got 4 perfect powers in there, so I can take the 4 perfect powers out, and I'm left with 1x, the 1x right there inside of the radical. The same thing's going to be true with cube roots. So I'm going to think 3 will go into 11 3 times with 2 left over. So when I take the cube root of this, tells me that I can take out x cubed, and this tells me that I've got x squared left inside. Then I'll do the same thing with this fourth root of x to the 15th. 4 will go into 15 3 times, so I'm going to take out x cubed, and 4 going to 15 3 times with 3 left over, so then I have 3 more x's inside that are not perfect. So just a reminder on those. So let's go back up and go to example 3. So here I have the fourth root of 162 into the 9th. So I'm finding a fourth root. So I'm going to come back over here and look at my perfect fourth powers and think if there's one of these that will go into 162. Oh, look, I believe 81 will do the trick. So 162 I can think of in terms of 81 times 2. And then I've got my n to the 9th. So the fourth root of 81, go back over here, the fourth root of 81 is 3. So this is going to be a 3. I can take that out. That's perfect. And the 2 is left over inside. And then the fourth root of n to the 9th, say 4 will go into 9 2 times with 1 left over. All right, this next one's a square root of 125. So one square root of 125, we know that that's a 25 times 5, and then I have x cubed. So it's a square root, so that's going to be a 5. The square root of 25 is 5, and then it leaves a 5 inside. And then for x cubed, 2 will go into x once with 1 left over. Then the cube root of 54, so I'm going to go back over here to my cubes and look for something that, here's my cubes, that there's not a 54 on the list. But 27 will go into 54 2 times. So I'm going to make this be the cube root then of 27 times 2. And then I've got my x to the 6th, y to the 8th. So the cube root of 27 was 3, and then I'm left with a 2 inside. Then 3 will go into 6 2 times exactly, so x squared comes out. 3 will go into 8 2 times, so y squared, and then there were 2 y's left over right there. And this is a little cube root thing right there on that. So 3x squared, y squared, cube root of 2y squared. All right, so give a really good try to D and E. All right, and so lastly, the quotient rule, and again, remember, if we have them separately, we can consider them together in this case. I think that makes it a little bit easier. So then I can reduce my fraction. 20 divided by 5 is 4. And then the square root of 4 is 2. I'm going to do the same thing over here. So this one, it's got a 2 on the outside, but I guess I should make this big square right there. So this is really like a 1 up here on top of that. Then I have a 50, then x. See, these are, notice what's on the inside. The 2's on the outside, but the 50x and the 2 are on the inside. So then I'm going to reduce that fraction inside. 50 divided by 2 is 25, and then x. And the square root of 25 is 5. So that's going to make us have 5 halves the square root of x. And finally, this really messy looking thing over here, we're just going to, again, think of this, the 7's on the outside. It's like a big, I'll put it as a big 7 on the outside. And this is a cube root. And then I have 48 x to the 4th y to the 8th over 6y squared. Then I'm going to reduce my fractions inside there, cube root. So 48 divided by 6 is an 8. Then I have x to the 4th. And then y to the 8th canceled with y to the 2nd gives me y to the 6th. So then I'm going to have a 7. Square root of 8 is, cube root of 8 is 2. Cube root of x is x with 1 left over. And the cube root of y to the 6th gives me y squared right there. So 7 times 2 is 14x y squared cube root of x for my final answer on that. And now try these last 3 problems.